So since the degree of top polynomial is bigger than the degree of bottom polynomial, we're going to divide to find the slant asymptote. So slant asymptote exists in this case, so we're not going to have a horizontal asymptote for this problem because degree of top, degree of the bottom. Case then we don't have horizontal asymptote, no horizontal asymptote, but we do have a slant asymptote, and we can find that by long division. So I'm just going to take this as the bottom one is a divisor, and the top is a dividend. So I will divide this 2, and the quotient will be the slant asymptote. And when we do that, we just divide the first terms, so that's x, and then x here, x to the 4 minus 8x cubed squared minus 6x, and then change the sign, negative, positive, negative, positive. So this 2 cancels, and we'll get x cubed here. And 21 minus 13 is 8, so this is plus 8x squared, and then this is negative 57x plus, and we'll do it again. So we take this and divide it by x cubed, so that's plus 1, and that's x cubed minus 8x squared minus 8x squared, and then plus 13x minus 6. And then when you change the sign, make it negative, positive, negative, positive. So these 2 cancels, and we'll get 16x squared, and this is negative, so that's going to be 70, negative 70x. This is positive, so this will be 114. Okay, so now this is smaller than the degree of the remainder is smaller than the degree of divisor, so this will terminate this process. So this is what we need. This is what we're going to call the slant asymptote. Slant asymptote is y equal to 1. Okay, so no horizontal asymptote. Horizontal asymptote does not exist. Now what's left is to find a vertical asymptote. So to find a vertical asymptote is we make the bottom 0. So we're just going to set the bottom and set it to 0 and solve it for x. Set this to 0 to solve it. Okay, this is a cubic function, so we're going to use the rational 0 theorem to find the 0 of this function. Okay, so let me do that on the next page. So we have x cubed minus 8x squared plus 13x minus 6 equals 0. And so rational 0 theorem was like we try the factors of this guy, right? So plus minus 1, plus minus 2, plus minus 3, plus minus 6. So one of this guy is going to be the 0 of the polynomial because this coefficient is 1. So when we divide by 1, we still get the same list. So I'm going to try start with 1. I'm going to try 1. So when I plug 1, it's going to be 1 cubed minus 8 times 1 squared plus 13 times 1 minus 6. And this is negative 7, and this is plus 7, so it's 0. So luckily, the first number worked. So therefore, x equal to 1 is one of the zeros. One of the zeros of this polynomial. So x equal to 0 is a horizontal asymptote in this case, but we're going to find the other one. To find the other one, I'm going to divide, right? Because the factor will be x minus 1, and then the polynomial is this, so I will divide it and figure out the other 0. So again, I will just divide the first term, x squared, multiply it, x cubed minus x squared, change the sign, minus plus, this will be negative 7x squared plus 13x minus 6, and then divide it, you'll get negative 7x squared plus 7x, and then subtract it. So you get plus here minus here. This will be 6x minus 6, and then it will be 6, so 6x minus 6. When you subtract it, you get 0. So this is the other one, and I'll set that to 0. So x squared minus 7x plus 6 equal to 0. And this will be x minus 6, x minus 1 equal to 0 when you factorize it, and when you solve it, it's x equal to 6, x equal to 1. So I have two solutions here, but one is repeating. So therefore, vertical asymptotes are x equal to. Now to find the answer to other question, for instance, where function is increasing, decreasing in local maximas, you need a graph. So that cannot be done by hand. And what my suggestion is, okay, enter the function in your calculator and look at the graph and see where our maximum, where our minimum. So the best way to answer those questions is plug in the function using your calculator. So, but this portion can be done by hand, which we didn't